So just to remind us, a rational number is any number that can be expressed as a quotient of two integers, as a fraction, okay? If you can express it as a fraction, it's going to be a rational number. Now, let's look here at negative 8. Well, negative 8, I think we could write that like this, couldn't we? Negative 8 over 1, so that's a rational number. We'll check that one off. What about negative 4? Well, probably the same reason here, right? Negative 4. Negative 4 we can write as negative 4 over 1. Or if we want, how about negative 8 over 2? Or if we like, how about negative 32 over 8? Dot, dot, dot. Lots of ways to do that. So that one's going to work. Now, up here at the top right, what about this number here, this negative, get it to right here, this negative 0.777, and the dots mean that it just keeps on going forever. Well, this one's a little bit tricky, and unless you've seen something like this before, you might not recognize it. But it turns out this is equal to negative 7 over 9. You might try it on your calculator. You get a repeating decimal, negative 7 over 9. In fact, if you try something like this, 0.55555, it keeps on going, that's going to be negative 5 over 9. Or you've probably seen this one, right? 0.3333, on and on. That's equal to 3 over 9, or 1/3. So it turns out that that negative point repeating 7 is a rational number. Now 2, well, 2 we can write as, well, let's get it to write properly here. 2 we can write as 2 over 1. We could even write it as 100 over 50. Now, lots of ways to do that. So 2 is rational. 3 is rational. Now what about this 26 over 5? Well, it's a fraction already, right? 26 over 5. 26 over 5 is already in terms of a fraction. So that's rational. And this last number here, pi, well, this number here is 3.14159 dot, 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 keeps on going forever with no repeating patterns. So this is not rational. This is not rational. So if it's not rational, we call it irrational. And that's it. In number 13, I think we can see the rationals right away. I'm going to claim that negative 7 is rational because negative 7 I could write as negative 7 over 1 or negative 14 over 2, so on. How about the 0? All right, let's do the 0. Well, 0 you can write as 0 over 1 or 0 over 2. These are all equal to 0. 6/7, that's a fraction already, right? 6 over 7. Let's go down to the 4. Now the 4, of course, is just 4 over 1. So I think these are somewhat obvious. Let's check out this negative 1.6, and then we'll take a look at the square root of 6. Now let's look at this negative 1.6 up here at the top right. You know what? We could write this like this. All right, just for a minute here, I'm going to forget the negative. Okay, let's just forget the negative because we can always put that on the end. So if you just had 1.6, maybe this is really just a way of writing 1 plus 0.6. That's really what it is. Now this I could write as 1 plus 6/10. Now this I could change into an improper fraction like this. I could multiply and then add. So I'll get 1 times 10 plus 6 over 10. Order of operations, 1 times 10 is 10 plus 6 over 10. So this gives me 16/10. And that's certainly a fraction, right? An integer. This is just an integer over an integer. And if I just put the negative on it, it really doesn't change anything. So I'm going to claim now that this negative 1.6 up here at the top, right? Up here at the top, let's claim that that is a rational number. Now, the last one we have to deal with is the square root of 6. So here's how you can think about these. When you see a square root, if you cannot get a nice even number, not necessarily even, an integer out of this, if you don't get an integer out of it, it's going to be irrational. So for example, if I did this one, square root of 25, we all know what that is. That's 5. I got an integer. If I take the square root of 121, that's 11. That's an integer. But the square root of 6, I don't know. I can't get an integer out of this, right? This is not an integer. And if it's not an integer, then it is not a rational number. All right, so I'm going to claim now that this up here at the top left, that is not a rational number.